So the take-up for these questions, the first question said, what integer must be subtracted from negative 74 to give negative 59? So that means this. Negative 74 minus some number has to equal negative 59. So when we could basically just use algebra for this if we wanted, and to get rid of subtracting 74, we could add 74 to both sides, and we get 15. But then that's what negative x equals, so positive x must be negative 15. So that would be probably the easiest way to approach this question. Or, you could kind of guess some numbers. A lot of you said positive 15, so you forgot that when you subtract a negative, it's like adding, in which case makes it bigger. If you're in grade 7 and you haven't learned integers, you will, and so you were a little bit at a disadvantage. But negative 74 minus 15 will actually get you to negative 89. So when you subtract 15, you're actually getting smaller, which with integers, you're actually moving farther away from 0. Whereas if you subtract negative 15, that's like adding 15, in which case you're getting bigger and moving closer to 0. So that's the answer to number 1. So to answer number 2, what I would do is I would get a common denominator. So I'd figure out a number that both 9 and 25 go into. The easiest way to do that is to just do 9 times 25, and you get 225. And that means 9 times 25, so you do 1 times 25 there, and then that one you had to times by 9, so that becomes that. So you'll end up with 16 over 225 if you're using your fractions. Then all you have to do is square root this. The square root of 16 is 4, and the square root of 225 is 15. And that's going to be your answer for B. So number 3 was a tricky one. It asked about the number of cubes between 8 to the 6 and 5 to the 9. And a cube, remember, so a square, let's go back. A square means something times itself. So for example, 25 is a squared. So 5 squared, that's a squared. Or 6 squared, that's a square. So cubes then would be something cubed. So one way to do this would be to use your exponent rules and break this down a bit. And so when we break this down, okay, we end up with so 8 is like saying 2 to the 3, and we're raising that to the 6. So another way of writing 8 to the 6 is 2 to the 3, which is 8, to the 6. Then what we can do is, we know that that just equals 2 to the 18 using the power to a power rule. So when we're thinking of cubing something, so that becomes 2 to the 18, except cubing something means we want to write it with the 3 on the outside. So again, if you're thinking of your power to power rule, then this must be a 6 on the inside, which is 64 cubed. So that looks, I know that looks very complicated. So what we did was we changed 8 to 2 to the 3. Then we used our power to power rule, and we thought about how could we create this number 2 to the 18? How could we create a cube out of this number? That means it must be something to the 3. That's what a cube is. It's something to the 3. Then we broke down what was 2 to the 6. It was 64. Now let's do the same for 5 to the 9. So this one, however, we can't rewrite 5 as something, so we can go straight to breaking this down into a cube. So how could we break 9 down into something cubed? Well, it must be 5 to the 3, which is 125 cubed. So that means that the number of cubes between this number and this number must be between 64 cubed and 125. So you'd have 64 cubed, you'd have 65 cubed, you'd have 66 cubed, etc., all the way up to 125 cubed, except it said how many are between, which means you don't include that and you don't include that. So to find how many, you could count. The fastest way is to just do 125 minus 64, but then because you're not counting the beginning, you have to also take away 1, and you end up with 60 in total. So think about it. An easier example would be how many numbers are between 4 and 10. So when I look at between 4 and 10, I initially think, oh, let's just do 10 minus 4, and there must be 6 numbers between. However, if you're not including 4 and 10, there's actually only 5 numbers between, which is why we had to take away that extra 1. So that's the answer. That one was a very complicated one. I don't know that anyone actually got that one right. So for number 4 or D, you had to look at these tiles. So here's your J-shaped tile, and the easiest way to approach it is to notice that 2 of these J-shaped tiles actually fit together. So I can put another J-shaped tile right here, and I know that's not drawn very well, but that's a J-shaped tile, and so there's one here and there's one here. So 2 of them fitting together form a 3 by 4 rectangle. So that's your first kind of step. Then you had to think about a 10 by 15. So picture, your 10 by 15 and picture how this might work. So if you did a 3 here and a 3 here, so the 3 there and the 3 there means you're left with 4 here, which means you can do your 3 by 4s and you can get 3, you can go like this and get 6 3 by 4s, but then you're left over with a 3 here. And so you're actually going to have to do a little bit of work in terms of switching, so I'm not drawing this well, but you have a 3 and a 3, which means this has to be a 4 by 3 and a 4 by 3 and a 4 by 3. And you'll be able to get 5 of those across the bottom. And you'll be able to do a 3 by 4, a 3 by 4, a 3 by 4. You'll be able to do 3 of those across and 3 of those across. But then you have some problems in this area. So in this area, I'm going to draw that. I'm going to erase that for a second. In this area, and I know this isn't clear because I've kind of messed up the drawing a bit, you're going to end up with, you're going to have some space here that is 4. So you're going to have 6 left over here. You're going to have a 6 by 3 left over. So what you can make is a 3 by 4. So right there, you can make a 3 that way, a 3 that way and a 4 that way. And then you're left with a 3 by 2 space. Whoops, I just erased. You're left with a 3 by 2 space right there. That is going to be the leftover tiles. And so the least number of tiles that you can have, I believe, would be 6, because that's going to be your leftover. So again, I know that was kind of confusing. What I did was I paired up 2 J shapes together. That gave me a 3 by 4 tile. Then I thought about how I could break my 10 by 15 floor up using that as best I could. So I started by placing my 3 by 4s, but I ended up with a 4, 4, and a 4, which meant 12. I had 3 left over there. If I went a 3, and a 4, I could fit them in, but then I ended up with a little bit of problem in this area. I was left with a 3 by 6 space in this area. Within that space, I could fit a 3 by 4, which left me with a 3 by 2 space, and so that would be the answer to question 4. Okay, so for question 5, that was the 4-digit positive integers consisting of distinct non-zero digits, and they had to equal 14. So they were non-zero, they were distinct, there were 4 of them, and they had to equal 14. So the way I would approach this is I would start by thinking about 4 numbers that are different that add up to 4 numbers, that are different and not 0 that add up to 14. So for example, I could have 1, 2, 3, and 8. I could have 1, 2, 4, and 7. I could have 1, 2, 5, and 6. I could have 1, 3, 4, and 6. And I could have 2, 3, 4, and 5. If you play around with this, and my advice to you is to start, follow an order with it, and so you don't miss any. but you're going to find that these are the only 5 numbers that will add up to give you 14 that are different numbers that aren't 0. Okay, so once you have that, we have 5 different numbers. Each of these numbers, and this is something you're going to learn in, I think, grade 12 data management, if you take that course, is about arrangements of numbers. And with these numbers, I could arrange them. I have my digits in 4 different spots. So I could, in this spot, I could put my 1, my 2, my 3, or my 8. Any of those would work. So I have 4 possible numbers I could put in that spot. Once I put 1 in my second spot then, I'm down to only 3 numbers left. For example, if I put the 8 there, then I could put the 1, the 2, or the 3 there. So I only have 3 possible numbers left. Or again, if I put the 3 there, then I only have 1, 2, and 8 that could go there. Because remember, I can't repeat the numbers. That means in my next spot, I'm left with 2 numbers that I could place. And my last spot, I'm left with 1 numbers. To find out how many possible arrangements there are, I actually just multiply those together. Or, for you grade 8s that have been learning this, that's the same as 4 factorial. So there are 24 different ways that I can write 4 numbers. 24 different arrangements. You could certainly list them all if you wanted to, but that's going to be a lot of numbers to list. What you're going to notice is each of these have 4 distinct numbers. So this one will also have 24. This one will have 24. This one will have 24. And so will this one. Then what you're going to notice, well, if I have 5 different numbers that can all be written in 24 different ways, that is going to be my answer. So that is all the different questions. I know that it was kind of confusing. I was kind of scribbling and going through, but I thought it was important to at least have a chance for you to see how to do some of them. If you have any questions about any of them or you want to go over anything with me, just come and see me. I'm happy to sit down with you and go over these with you.